This is the opener for Geometry Chapter 10, Lesson 6, and I would encourage you to try as much of this as you can on your own, and then use the video to help if you have questions. So please pause and try some on your own first, and then use the video to check. So the first question is to graph circles and lines, and the first equation is x squared plus y squared equals 1. So I know that the center of that circle is 0, 0, and that the radius squared is 1, and so then the radius is 1. So always a good idea to write down the center and the radius when you're going to graph the circle. And it's just going to be this little baby. A little lopsided there. Alright, so that's A. And then B is a circle with a center of -2 and 7 and a radius of 3. Remember that this represents the radius squared, so if this value is 9, then the radius is 3, and the center is -2, +1, 2, 3, 4, 5, 6, 7, with a radius of 3. And so I get that circle. And then we're supposed to find the equation of the circle shown. And the center of this circle is 2, -2. And the radius is 5. So the equation will have this structure. Since the radius is 5, this is going to be 5 squared, or 25. Put the x in the first factor, the y in the second, and I get x minus 2 squared and y plus 2. Remember that if this is a minus, that center will be a positive value, and if this is y plus 2, the center will be a negative value. Then just for review, we're supposed to graph this line. X minus 3 equals 9, and so I'm going to change it to y equals form by subtracting an x from both sides, and then divide by -3. So y is equal to -1 divided by -3 is +1/3, and 9 divided by -3 is -3. And so then when I graph that, I get this circle, or this line that goes through -3 with a slope of 1/3. And then the last part of this question is a challenge. It is optional, but if you're interested in the challenge, you should pause the video and see if you can figure it out yourself. It is to find the equation of a line that is tangent to the circle graphed at the point 6, 1. So the circle graphed here is meaning the circle that was already graphed on the diagram, and you are looking for a line that is tangent to the circle at the point 6, 1. Now remember, what it means to be tangent of the circle is that it just brushes the outside of the circle, and what makes it tangent is that the tangent line has to be perpendicular to the radius at that point. So that's the radius, and the slope of that line is 3/4, which means the slope of the tangent line is going to have to be the opposite, so negative, and the reciprocal, so 4/3. Again, the slope of the orange line is 3/4, and the slope of the tangent line is going to be perpendicular to that. So if this slope is 3/4, then the tangent slope would be -4/3. And we could graph that down 4 over 3, up 4 over 3. Oh, I didn't go over 3, that's why it's not looking so good there. So that line is tangent to the circle, and to get the equation of it, I would do y minus 1 equals negative 4/3 x minus 6. And then I would distribute and combine like terms, and if you get it right, you would get negative 4/3 x plus 9. And you could even do this 1, 2, 3, 4, and you would end up getting that that point is 0, 9 up there. All right, so moving on. These problems are not challenge problems. They are required for all of you. I think that it would have been good if the problem had had a letter E here for that. So why don't you go ahead and put that in. And then it starts with finding, say, angle A. You don't always have to find these in order, but they often go in order. So angle, if this arc is 110, then the inscribed angle is half of that. So half of 110 is 55. And the tangent line, this is probably the one that you're least familiar with, but I probably should have told you that this was a tangent line. So pretend that said tangent there. And if that is tangent, then this angle has to be a right angle. So that means that angle B is equal to 90 minus 55, or 35 degrees. And I don't think angle C is the best one to find next. I'm going to go ahead and find angle D. And remember that the central angle and the intercepted arc are equal to each other. So angle D is 60 degrees. And then there's some options for finding angle E. Angle E is equal to this arc, and since this is a semicircle, then I know that this arc is 120 degrees, and so I could get angle E using my knowledge of the circles is 120 degrees. Or I could just know that these two were supplementary, and then they also would have come out to be 120. And then the last one I'm going to find is angle C. And I want to take advantage of the fact that the radii of any circle are always equal to each other. Radii is the plural of radius. So if you were talking of two values that represent the radius, then I would call them the radii. And since this is a radius of the circle and this is a radius of the circle, then I know that those two lengths are equal, as is this one. But I care about these because then that means that this triangle is isosceles, and that these two angles therefore have to be equal. So if this is 120 degrees, then there's only 60 degrees left for these remaining two angles, and half of 60 then is 30 degrees. So these would both be 30 degrees. All right, you should pause and try number 3 on your own if you haven't already. Angle A in this case is half of 100. Angle B is half of 110. The angle at the top inside the circle would be 180 minus 50 minus 55, which would be 75, which means that this one is supplementary to 75, or it will be 105. That one. this is bothering me a little bit here in finding this value, because this is not at the center of the circle and it's not on the circle. So you couldn't have counted on the 110 telling you that this was 105, but you can get the 75 for the top of the triangle and then the supplementary to 75 right here. All right, moving on. This is just practicing the vocabulary, and I'm not sure why I stopped at D, so we're going to add a couple more things on there as we go. But it says to label the center of the circle A, and then draw a point on the circle and name it B. And then draw a radius from A to B. This is a radius. And then it says to draw a chord on the circle from B to a new point called C. So I'm just picking any point on the circle, and this is a chord. This one is a radius. Then draw a chord on this, so I did that. Draw a line tangent to the circle that passes through C. So you're just going to estimate it here, make it look like a tangent line. And then there's two other lines that you should know by name also. One of them is the diameter. I'm just going to put a diameter on this circle. And notice that the diameter also includes a radius, and that the radius and the tangent line form a 90-degree angle. So the significance of a line tangent to the circle is that that intersection will form a 90-degree angle. And then the last vocabulary word you need to know about a circle is called a secant line. And a secant is similar to a chord, but it's a line instead of just a segment. So a chord is a segment and a secant is a line. A tangent is a line also, and so I should have arrows on the end there, and I could put the word line, tangent line. And the chord is just a segment that stops at the endpoints of the circle. The diameter is a segment and the radius is a segment. But the tangent line and the secant line should have arrows on the end going on forever. Thanks for watching.